Good morning. My name is Dr. R. Ramasamy. I am Assistant Professor, Department of Physics, National College. Today I am going to take the theory of practice of refractive index of the material of the prism. This is a very important one. So first of all, you have to know what is refractive index. Refractive index is defined as the ratio of velocity of light in vacuum to the velocity of light in medium. That is, the refractive index is denoted by mu. Mu is equal to C by V. That is the general definition. So here, the figure A, I am given the refraction through a prism. What is prism? A prism is a transparent medium, consists of three faces, out of which two faces are polished. So that polished two faces are known as the refracting faces. The angle between the two refracting faces is the angle of the prism, that is denoted by A. The third face is grounded, that is known as base. Here I have shown BC in figure. So here the formula for refractive index is mu is equal to sin A plus D by 2 by sin A by 2. A is the angle of prism, D is the angle of minimum deviation. So here, how to find the angle of prism, how to find the angle of minimum deviation. So for finding capital A, so in figure B, I have placed the prism here. The prism is placed on the prism table where the refracting edge must face the collimator. Refracting edge must face the collimator in the case of measuring the angle of prism. That is shown in figure B. On the other hand, while measuring the angle of minimum deviation, here the light from the collimator enters the refracting phase. Enters the refracting phase, and then we can measure the angle of deviation. First of all, you have to know what is spectrometer. Spectrometer nothing but it is an optical instrument. So three major parts are important in spectrometer. One is telescope. இது தமிழில் தொலைநோக்கி அப்படின்னு சொல்லுவாங்க. This is known as collimator, இணையாக்கி. This is known as prism table, முப்பட்டக மேடை. In the telescope, you will have the eyepiece. You will have the eyepiece. இதுக்கு பேர் கண்ணரகு கருவி அப்படின்னு பேர். Now, so first of all, there are three important adjustments in the spectrometer. The first adjustment is the telescope. So in telescope, you have to see the eyepiece, through the eyepiece, whether you are getting the cross wire. That is very important, because in the diagram I put it as source of light. Yes, that source is monochromatic source. The name of the monochromatic source is sodium vapor lamp. So monochromatic means single wavelength. So we will get the slit only in the vertical shape. So in the cross wire you will have plus, that is horizontal, vertical intersecting. The vertical cross wire is very important. So first adjustment, through the telescope you have to adjust the cross wire. Second one is collimator. Collimator is used to receive the parallel rays. So second adjustment, by using the screw in the collimator, you have to adjust for the slit. Third one is prism table. So here in the prism table, you are going to mount the prism here. So you have to adjust the leveling screws of the prism table. So in order to check whether the prism table is correct, you make use of a split level. Split level. This should be actually used by in the construction of building. அதாவது என்ன சார்னா கொத்தனார் வச்சிருப்பார் நேராக வச்சு பார்க்கறது லெவல் கரெக்டாக இருக்கா. ஸோ யூ கேன் அட்ஜஸ்ட் பை யூஸிங் தி லெவலிங் ஸ்க்ரூஸ். ஓகே, நவ் யூ ஹேவ் டு டெல் ஃபர்ஸ்ட் ஆஃப் ஆல் ஹவு டு ஃபைண்ட் தி ஆங்கிள் ஆஃப் prism. ஸோ யூ பிளேஸ் the polished face towards the telescope, and then you can see. So you are going to get two reflecting rays while measuring the angle of prism. The left side, you move the telescope and measure the reflecting ray, and you have to make use of Vernier A and Vernier B reading. So there is a vernier disc 360 degree, there are two verniers. One is vernier A, another one is vernier B. You have to know the difference between vernier A and vernier B is always 180 degree. Value of one main scale division is 30 minute here, or half degree, or you can say 0.5 degree. So left side you keep the telescope. First you take the reading of the reflecting ray. You note it both for vernier A and vernier B, and then you move the telescope towards the right side. Again you take the reading of the reflecting ray. You note again the reading vernier A, vernier B. Then you take the difference between two vernier A and the difference between two vernier B. You will get 2A. That is angle of prism. 2A is equal to, you will get some value. For example, I can say prism is an equilateral triangle. You know, in a triangle, the sum of the three angles is 180 degree. So each angle is 60 degree, 60, 60, 60. Suppose for example, you will get it as 2A is equal to 120, A is equal to 120 divided by 2, A is equal to 60 degree is the angle of the prism. This is the first part. Second part is you have to find capital D, angle of minimum deviation. For that case, what you are going to do is you have to place the prism like this. Now you can say, you can see collimator, prism, telescope or collinear. But you have to take the refracted reading. You just place the prism like that. You bring the telescope here, you will get the refracted ray. What you have to do is, you have to move the prism table towards the direct reading, and then at you move the prism table slowly towards the direct reading. At one particular stage, it will turn opposite side. That place is known as the value of minimum deviation. You note the reading both vernier A, vernier B. After that, you remove the prism, you bring the telescope straight. You straight away you can see the slit through the collimator. You measure the direct reading. So and reading you also have vernier A and vernier B. So the difference between two vernier A, you write it, and the difference between two vernier B, you write it. So average of these two gives the angle of minimum deviation, capital D. The first part we calculated the angle of the prism A. Second part we are calculated angle of minimum deviation. While substituting in the formula, mu is equal to sin A plus D by 2 by sin A by 2, we can calculate the refractive index. Generally, you will get the refractive index value ranges from 1.5 to 1.62 like that. We can also find the refractive index of the liquid by using the prism. By pouring the liquid into the prism, we can calculate the refractive index of the liquid also. Refractive index is, since refractive index is a ratio, it has no unit. That is very important one. Thank you very much.